Hey, Bonald Eagles, Ms. Barker. We're going to get into solving compound inequalities again, just another day to help strengthen this. So take a moment to pause the video, get this copied, and then we'll get started. Alright, so as you can tell, we're now stepping into the expectation of being able to translate first. We have 2 times the number plus 1 is greater than 5 and less than 7. Okay, so we know we're dealing with 2 times the number plus 1. We know we have that. This amount has to be greater than 5. This amount has to be less than 7. Remember, I've kind of been mentioning in class the whole need for the least to greatest. So I'm going to want the 5 over here on the left. I'm going to want the 7 over here on the right. And I'm going to want you to recognize that this problem is an AND problem. Got the word right here. This is an AND problem. So I'm going to put a 5. I'm going to put a 7. Less than. Less than. So 5 is less than 2n plus 1, and also 2n plus 1 is less than 7. So now that we have that figured out, now that we have this written in this compound inequality form, now we can do a breakup and solve the thing. So I'm going to write 5 is less than 2n plus 1, and 2n plus 1 is less than 7. This one, subtract a 1 from both sides. 4 is less than 2n. Divide both sides by 2. 2 is less than n. Complete reversal. N is greater than 2. Now, let's consider the other case. 2n plus 1 is less than 7. Subtract 1 from both sides. 2n is less than 6. Divide both sides by 2. N is less than 3. Next, we're going to graph. I'm going to use the left-hand side. I'm going to use the right-hand side, the space that I have, in order to create my graph. The key thing is I need a 2. I need a 3. Really don't care about anything before or after in between. Just need these key numbers. I need n to be greater than 2. So open circle, shade to the right. I need n to be less than 3. So open circle, shade to the left. This is an AND problem, so I only end up with my combined shading. Start at 2, finish at 3, shade in between of our number line. So we end up with our solution in a solution set of all values n such that 2 is less than x is less than 3. Notice, started at 2, ended at 3. Started at 2, ended at 3. Shading in between. Shading represents all those x values. There's my x values. 2 is less than all of that. 3 is greater than all that. So x is less than our 3. So this ends up being our solution. Alright, so pause the video to copy whatever you need, then we'll take a look at the next. Alright, so please pause the video again so you can copy this, and then we'll take a look. Okay, so this problem we have is a number minus 1 is at most 9, or, so it's an OR problem, 2 times the number is at least 24. Alright, so our number minus 1 is at most 9. For it to be at most 9, it can be less than 9. It could actually be equal to 9. So that would be our number minus 1 is at most 9. Or, so here's my word or, 2 times the number, so 2n, is at least 24. If it's at least 24, it has to be bigger than 24, or it could be equal to 24. So 2n is greater than or equal to 24. Solve the left-hand side, add 1 to both sides. N is less than or equal to 10. Solve the right-hand side, divide both sides by 2. N is greater than or equal to 12. All right, this is what we need to graph. So we'll get that set up. I need to make sure I'm including a 10 and I'm including a 12. I hope you're starting to see that really the graph is part of our work. It's part of our preparation. It's part of seeing the problem. It's the solution like this that in the end is what I'm going for. But I do still want to see the graph. So n is less than or equal to 10. Close circle at 10, shade to the left. N is greater than or equal to 12. Close circle at 12, shade to the right. This is an or, so we just piece it all together. Close circle at 10, shade to the left on my number line. Close circle at 12, shade to the right on my number line. So in the end, we end up with the solution of n such that n is less than or equal to 10, or n is greater than or equal to 12. Okay, pause the video to make sure you have this, and then we'll come back. Okay, before you write anything down, let's just take a look at this problem. Clearly an AND problem, so we would do our separation. We'd multiply both sides by 2, giving us a negative 6 is less than or equal to the 4x plus 1. Subtract 1 from both sides, so negative 7 is less than or equal to 4x. Divide both sides by 4 to get a negative 7/4 less than or equal to x. Complete reversal, so x is greater than or equal to negative 7/4. By the way, notice that gives us a closed circle shading to the right. In the other case, multiply both sides by 2, 4x plus 1 is less than 10. Divide both sides by 4, x is less than 9 over 4. So open circle at 9 over 4, shading to the left. Here's our shading in between. Therefore, x such that negative 7/4 is less than or equal to x is less than 9 over 4. So take a moment to get this copied down to make sure you understand each piece, but keep this side open because I'm going to show you something different. So pause the video, do your writing, then we're going to look at this problem again. Okay, you are welcome to do these type of problems this way every single time. And quite honestly, anytime you have a negative coefficient in here, it's probably will be easier to do it this way. But I want to show you why I don't do it this way all the time. Think of what I had to do here and here. In both cases, I had to multiply both sides by 2. Well, what if I just don't break it up and I leave it as is? If I think of multiplying both sides by 2, both sides by 2, that's going to be this by 2, this by 2, and this by 2. Negative 3 times 2 is a negative 6. Less than or equal. This fraction times 2 is just the 4x plus 1. Less than 5 times 2 is 10. Think of what I did both here and here. I subtracted 1, I subtracted 1. Let's just do that throughout. Let's just do a minus 1, a minus 1, a minus 1 all across the board. That gives me a negative 7 is less than or equal to a 4x is less than 9. Think of what I did from here to here, what I did from here to here. In both cases, I divided by 4. All right, let's do it here. So divide by 4, divide by 4, divide by 4. Giving a negative 7 over 4 is less than or equal. 4x over 4 is just x, is less than a 9 over 4. I kept everything together, solved the whole thing at once, and I still got the exact same solution of x such that negative 7/4 is less than or equal to x is less than 9 over 4. I got the exact same answer. The graph would end up being exactly the same. Negative 7/4 is here, 9/4 is here. We've got a less than or equal, so we have a closed. I've got just a less than, so I have an open. And for the x being in between, my shading is in between. So if I needed the graph, I could go from here to here to make the graph. Now, I will tell you, I'm not going to require you to do it this way. But I understand some of you are going to much prefer doing it this way if you are able to attend to the details. And again, unless you're one of mine who makes 99 and hundreds just about all the time, I really don't recommend this if you have a negative coefficient, much less if you have variables here and here, because then you really have a mess to take care of. But when it's just this simpler case, and plain old number here, a plain old number here, this x has a positive coefficient, go for it. Glad you took care of your notes. I'll see you in class.